Here at the Goddard Space Flight Center in Greenbelt, Maryland, we are building the most advanced and largest space telescope ever constructed, the James Webb Space Telescope.
With the big game right around the corner, we thought it'd be pretty cool to use a football to demonstrate some of the testing we do here at Goddard to make sure that Webb is ready for its mission. Launch is the most intense part of any spacecraft's mission, and we need to make sure Webb can survive its ride on the very powerful Ariane 5 rocket.
Ben Lavera, 2016 Maryland High School field goal leader, will help us demonstrate. Ben's kick imparts a force on the football of slightly more than 4 Gs. 1 G is the force you feel standing on Earth. During launch, Webb telescope components can experience forces up to 19 Gs, or 19 times their weight. Imagine your legs holding up 19 times your body weight. For humans, that's physically impossible. Webb's composite structure and components are built and tested to handle that.
We put the telescope and all of its components through a series of tests to prove that it can withstand the rigors of launch.
These tests include vibration tests, centrifuge tests, and acoustic tests.
We use this giant acoustic chamber and its very powerful sound system to mimic the sound pressures and frequencies we see on the Ariane 5 rocket during launch. Sound pressure waves can cause vibrations, which may be very damaging. We test in this chamber to make sure the rocket noise won't break anything.
We test every material used to build Webb to make sure it can withstand the stresses of launch and properly function in space.
Webb's instruments are designed to detect infrared light from the farthest objects in the universe. Our eyes can't detect infrared light, but we can feel it as heat. Here's where the heat from my hand warmed up this football and left a heat print on it.
To perform its mission, Webb's instruments need to be extremely cold, very near absolute zero or minus 459 degrees Fahrenheit. We don't want their own heat influencing the images, so we test everything cryogenically in large test chambers and make sure everything works as it should in the freezing environment of space. Materials can change dramatically at these cryogenic temperatures, not always how you'd expect. Let's see what happens to this football in liquid nitrogen, which is still about 70 to 100 degrees warmer than some of Webb's instruments. The balls in our rubber bladder shattered at this temperature, but wow, the outer shell holds together. Webb's instruments, on the other hand, are built to withstand such extreme temperatures. Not the sledgehammer, by the way.
Test, test, and test again is the key.
We'd rather have something break during a test on the ground where we can understand the problem and fix it than in space. Soon, the telescope will be heading to Johnson Space Center in Houston, Texas for some more testing before it heads to Northrop Grumman in California to be assembled and packed into a rocket. The telescope will be launched from French Guiana in 2018.
This football may not be space-worthy, but it sure works well here on Earth.
Check out nasa.gov/JWST to learn more about this incredible mission that is the follow-on to the Hubble Space Telescope.